Hello, welcome to my presentation for the IBM Coursera Advanced Data Science Capstone. This project was done as a final assignment for the course. I wanted to do something that was applicable in the agricultural industry, especially when it comes to the quality of fruit. I wanted to make something that would automatically detect the quality of different types of fruit. So on Kaggle I found a data set which inspired me that had three different kind of fruits and whether they were fresh or they were rotten. Then I also had the ambition to improve my deep learning skills. So yeah, that's how I came up with this project. I downloaded the data set from Kaggle. It contained thousands of images of fresh and rotten apples, bananas and oranges. I then manually transformed this in a different data set. This was because I do different sessions of training. First I'm going to determine whether they're apples, oranges or bananas. So what I did is combine all the fresh and rotten images together, and they will be all in the apples or the oranges or the bananas folder. And then as a second step it will determine for each whether they're fresh or rotten. So then all the fresh apples will go into the apples/fresh folder, for example. Alright, let's talk about technological decisions. Convolutional networks are most suited for image recognition. They are inspired by biological processes. Yeah, as you can see, I took this from Wikipedia, this quote, because I found it very clear that the reason why I used convolutional networks in specific. And then I used Keras and TensorFlow. Keras because Keras is a very low learning curve. It's very easy to use. The amount of code that's necessary to achieve your goals is very little. And I used the TensorFlow backend because TensorFlow is industry proven one of the best at the moment. I wanted to do some training on the GPU, but I didn't have any GPU, but it's very recommended to do so because training takes very, very long. So training 6 category was rather tricky. So that's how I said before. First, I decided let's determine whether they're fruit and which kind of fruit. So which are they, apples, bananas, or oranges. And then secondly, we will determine whether they're fresh or they're rotten. This link doesn't work. Let's just go. So here we have the fruit classifier. I will run through it. Here it does the imports. Here I define the image width and height. I came up with 32 by 32 because it was gave the best performance and also gave quite good results. I've also tried with very high resolution, but the results were lower than 32 by 32. I'm making some paths. And then I'm using Keras image data generator because it's very advanced, very flexible, and it gives a lot of different options, which if I would have to do it by hand would cost me a lot of work. As you see, it found 612 images for the test set and 2452 for the training set, and there are 3 classes. So this is my model. I've tweaked around with it, but in the end, the amount of layers and this kind of setup was the most efficient and gave the best results. It's very important to see that softmax has to be the activation because these are softmax is used for categorical cross entropy, and sigmoid, for example, is only if there's either one or the other. So. For the next session, when we look at freshness, then we will use sigmoid. I came with this optimizer. I also had very good results with Adam, for example, but I guess the best results I got with this one. So let's create it. It prints out the summary, and then the training starts. I adapted the values a little bit. I used actually 2000 and 15 epochs. But for now, for the preview reasons, let's keep it short. So there, it will start training. Yeah, and this may be interesting to also mention. The model I'm saving as a YAML. With the convolutional networks, it was not possible to reload the whole model from the HDF5 file. So that's why I save the model definition separately in a YAML. YAML is a nice format to, if you have it in version control, to see exactly where and which change you did over time. So next time I change the model, then I know exactly what has been changed. So let's see. So in a very short run, I got quite some accuracy already. Now it will do some evaluation probably. Well, in the meantime, we can continue with the next model. So again, we do the imports. We choose 32 by 32. And we create the images. There are under 70 images belonging to 2 categories. And just in case, we're here doing oranges. Then we create the model. As you can see, now we're using sigmoid and binary cross entropy. And also very important to notice, which I didn't mention in the other notebook, and we only have one output layer. So let's start the training here as well. And in the meantime, we can go back to the classifier, which has finished. So as you see here, the dense layer had 3 for the 3 categories. So let's save it. Now let's do the evaluation. In the meantime, we can go back to the other one. The other one is almost done. Let's call the next comments already. Alright, now it's doing some evaluation probably. Oh, this one is too high, let's put this lower. Alright, so these are end results. They're not very good, but well, we didn't do a lot of steps and a lot of epochs. Let's go back to the oranges. It's still finishing. Alright. I will quit this one for a second and I'll redo it. This is much better. All right. Well, that's quite decent performance for such a quick step. All right. So this is how the training works. And let's go back to the next slide. So as a deliverable, I wanted to create a sort of application. So I made a simple web app. I deployed it in the Google Cloud. The model has to be deployed manually. I basically generate all the files that I generated. I just pick them up and throw them in the web app, and the web app knows where to find them. Let's do a little presentation of the web app. So, I will go to bananas. Let's see. Copy image location. And it's a banana and it's fresh. Let's see what it finds if we put a rotten banana. This one looks quite good. And this is a rotten banana. it has been detected quite accurately. And now let's try the oranges. Rotten orange. Let's find a nice one. Let's try this one. It didn't detect it. I fear that the round lunar form of the orange makes it think that it's a banana. So then it cannot detect it. Let's try another one. Let's try this one. It found that it is a rotten orange. So it works for some, it doesn't work for all. Now let's go check out an apple. I had some problem with apples, so in this case I will just show you that it can it can detect both apples, red ones and green ones. This is an apple and it's fresh. Let's try the green one. It's an apple and it's fresh. Alright, so the model needs some more improvement, but it's doing quite interesting. Alright, so this has been my presentation. I hope it was useful for everybody. I hope that I can continue improving this model, because I want to see if I can actually get something useful around there, so that maybe farmers, for example, can use a device and they can automatically test whether the quality of their fruit. What I would like to do is, like I said, I want to develop this into a mobile app. Perhaps that you just grab your phone and take a picture. Perhaps also a pipeline that it will automatically train the model, and then I can automatically deploy it to the cloud with to the web app directly. Definitely I want to improve the accuracy, and for that I think I will need a GPU. So I'm trying to prep my old laptop with a GPU to see if I can improve the performance. Here's my GitHub project. You can find the code. The dataset is not there. You can download it from the location as specified here. I'm trying to explain a little bit how to get it running, how to deploy it, etc. Alright, thank you for listening.